welcome everyone to this session. It's probably the only session today that talks about Agentic AI, but on the JVM. I have a lot to show you, so let's just get into it. So what's behind the session, right? There is a story behind the session. I realized that all of the streaming platforms that I was using, over time, I began to miss the artists that I really like listening to. And I think that's just the way the algorithms optimize for you to be more engaged and not to be surprised or bring up artists from the past, right? So once this sort of started happening to me, I thought, okay, I do have a physical music collection, and that's sitting on the shelf gathering a fair bit of dust. So what can I do to start playing that and also being able to focus on my music more and really getting back to the music that I intentionally buy, right, and like to listen to. So what I did is I took my record collection and I put it into Neo4j. And then I built an agent, well, two of them to help me use it. And that's what we're going to go through today. So the graph is really represents my record collection, right? This is not a generic music catalog. It is very, very specifically the music that I own, the physical records that I own. So I'm going to take you very quickly through the graph model. It is very, very simple and very intuitive. You have artists, you have albums, and you have genres, and you have tags. Your usual properties on artists and albums. A couple of things I want to point out. So the whole concept of having an agent recommend music to you is really based on the shape of that graph and how artists are connected to other artists, right? That's why you see that we have a lot of similarity relationships. So I use GDS to calculate the similarity, a node similarity for tags to tags, genres to genres. Summaries, so you'll see that there's a summary on every artist and album. Now, this summary is a string, which is gathered from, or rather, it's an LLM, right? Now, because it's a music graph, the world knowledge it has about music is fairly reliable, good enough to write you a very nice summary. So that's what I went with, and then there are embeddings on those summaries, which is really important because these summaries give you that stylistic semantic meaning, and the relationships tell you how well connected your graph is, and clusters and so on, right? So all the similarity relations actually roll up into a similar relation, and that's what we are going to use today. Now, the data in the graph, if you collect records, Discogs is a fairly well-known platform for record collectors. What I did is I exported my catalog, I imported it into Neo4j, but because it doesn't have all the information I need, I leaned on MusicBrainz, which is a super good collection of music data. I actually downloaded their Postgres database. It's pretty massive, but you can do it overnight. And what I do is I look into MusicBrainz to fetch things like the MusicBrainz ID, start here, end here, and really factual information about the artist and the album that I don't yet trust an LLM for. Then you have your similarity signals, as we spoke about, and the embeddings on top. So if you have a look at the graph below, this is really just the artist force-directed graph. And you can already see, without me doing anything, some very, very definite patterns I have in my graph. So to the right, you will see fairly interconnected clusters. That is hard rock, heavy metal, classic American, British rock. Then you have this little vague cluster in the middle, a bridge in the middle with some classical, and then it kind of shoots off to a bit of Iberian and Portuguese, right? So this collection is what really serves to ground the LLM, to give me answers based on what I really like listening to, and not pick a random genre that I absolutely do not listen to and maybe don't have any interest in listening to, right? So this is the purpose behind having a graph with similarity that structures my tastes, right? So, two agents today. The first is a music discovery agent. Now, this one is a more of an interactive, chatty kind of agent, and it recommends what to play from my collection. Right, so it can recommend an album to me. It can suggest maybe an album that I should have in my collection. Um, and it can actually add that album to my collection. So this agent also helps me to expand my underlying graph. The second agent is also very interesting. This is a more autonomous agent, and what it does is it finds listening paths through my collection. So what's a listening part, right? I think this is important to grasp before we get through, what the stages look like. So so if you take an example, right? If you take the Beatles, for example, right? They didn't pop out of nowhere and start singing. They were influenced by Chuck Berry and Motown and some early skiffle. And what you see in the Beatles in their early stage is they had these very, very catchy tunes and a bit of rock and roll energy. But then as they developed their own style later, as they progressed, they lean more into psychedelia and non-Western influences like Indian instruments, right? And why is this important? Because they were one of the artists that influenced a whole number of artists around them at that time and even to today. And why this is important, and this tells you now why we have the similarities, is if you look at two examples I'm sure at least you relate to one of them, right? Two examples where you can actually listen and pick up that Beatles tone immediately is Oasis, right? So they were influenced by the early stage Beatles. It was big singable hooks, and but they added, of course, their own swagger, so they developed later. And then you have Electric Light Orchestra, which based itself on the later Beatles. So some lush harmonies, a lot of strings, a lot of studio music production, and this is important because when we build a journey across albums, what you want your ear to pick up is some thread holding them together. You don't want an abrupt change between genres, right? So this agent really does that. It uses Neo4j heavily to actually select the albums and build the parts, but where it steps in is to evaluate the quality of the path it builds. It identifies, okay, you have a gap, and you can have a gap, and I do have many gaps because my record collection is quite limited. It isn't very large, so there will be gaps where I don't transition well between artists, and then it will autonomously decide, okay, I'm going to go out and find the best artist that will bridge this gap. Go fetch it from Music Brains, add it to the graph, repeat till it reaches either a suitable path, or it gives up because can't do better with my collection. Now, before we get into the code, we this is based on the Embabel agent framework, right? It's a framework built on the JVM for agentic flows. What's cool about this framework is, I think, primarily the planning strategies. So the one it started off with, which is the one I actually use in this talk today, is GOAP, which is goal-oriented action programming, and it's a deterministic form of reaching a goal through a set of paths, through a set of actions, right? So Embabel works on the concepts of steps, and these are called actions, and then there are conditions which determine, the prerequisites and the post-condition for a particular step. And what it does is it basically, without an LLM to plan, it will look at what's the best way that I can get to this goal, right? And actually behind the covers, that's also a graph. It uses the A-star method. So we're going to look at that today. Fairly recently, there were two more planning strategies that were introduced. One is utility, more for chat-like situations, and then the supervisor, which is a non-deterministic sort of planning, which we're not going to touch today. Uh, other important uh, other important things to note about the Embabel framework is you use your domain, right? Fully type safe. There's no free-form text. If you refactor, your agents aren't going to break. Your logic isn't going to break. If you have a typo, you aren't going to break. So it's designed with testability in mind from the get-go, and it's built on Spring. So for enterprise applications, you can leverage, the already existing mature capabilities like dependency injection or observability and security. So we're going to jump into the first agent, a more simple one. And before I get into the code, I want to explain to you what it's doing so it's easier to relate to the code. Now, this is the flow for the music discovery agent. There are three possible things it can do. One is it can recommend albums from my collection. The second one is it can suggest new artists to explore. And this is purely a suggestion. It doesn't modify my collection. And then if I actually wanted to save that artist, then I've got to tell it, okay, go and save the artist. So the way it's set up is the user input, which is my prompt to the agent. This triggers off everything. Um, we have an LLM that will we have an LLM that will basically look at my query and produce a strongly typed object out of this, right? Now that object is a kind of discovery request. It can be one of these three. So what the framework does is it says, okay, I've got a discovery request in hand. Which one is it, and can I achieve the goal? And then it will route you through one of these three branches. You can vary, as you can see in here, you can vary the models that you use for every action, depending on cost or creativity and so on and so forth. And you can have a mix of everything. Doesn't have to be an LLM. You can see that the ad is really just service logic, where we fetch the artist from MusicBrainz. This is JDBC driver to Postgres. But we put in a little LLM at the end because remember, there are those summaries which don't really exist in MusicBrainz. So here we do a quick hop out to an LLM to fetch the summary, run the embeddings, refresh the similarity, the projections, and then we're off. Yep. Okay, so let's have a look at the first one. So I'm going to flip between a couple of demos, the code, and the explanation, so that you don't have to watch the code keep running. Okay, so the first question is it's going to pick something from my collection. Now, before I show you the code, and that's going to go off and do its thing, here's what this is really doing behind the scenes. So first of all, the framework has picked the music discovery agent with a 95% confidence. Remember, we have two, and it's picked it based on what goal it thinks I want to achieve. Then it gets into the planning phase. So it uses a blackboard, kind of like a heap, to store the objects, the current state, your requests, and so on. And it uses this to discover, or rather to determine what's the current state of the world and how can I get from the current state of the world to the goal, right? And every time an action gets executed, the state of the world obviously has changed. There are new objects maybe created, there are new results. It will reevaluate its plan to get to the goal, right? So it goes through the discovery request, recommend for collection, and then you have the goal achieved. So let's have a quick look and see if it finished. It actually did. You can see in here. So that snarky tone is really from the framework. I haven't figured out how to change the tone of the assistant talking back, but you can see it came back with these suggestions. And I'd also note that we could have run this as an MCP server in Claude. I have the results here, but I chose to run it from the terminal because that's really fast, and I don't want to keep you waiting in the demo. If you were to run it in Claude, you expose the MCP server. Very simple, just drop in the dependency and you're done. And you can connect it to any tool that uses an MCP server. So let's quickly get into a bit of the code. So we have the music discovery agent annotated with agent. This makes it as well an injectable, a discoverable Spring Bean. The description is important because that's what the agent uses to determine which, that's what the framework uses to determine which agent it should call. And then I've collapsed the implementation of the methods because that's not so interesting, but I want to show you what each of the actions look like, right? Remember, each of the actions represent a potential step in the path to achieve a goal. Now, in this case, we have three goals because the user could accomplish what they want in one of three ways in a single agent. So you have the recommend. We have an achieves goal, which basically tells the framework that, okay, the goal is accomplished. We can terminate now. We have an action which tells you what it does. But more importantly, because we're using GOP and we're not using an LLM to decide what the path is, the way Embabel works is it looks really at how to get to this goal from these, right? Your method parameters. So to be able to recommend something from my collection, it needs a recommend from collection intent, right? How does it get a recommend from collection and intent? The only way it can actually get it is by is from here. So we know that I've asked a question, the user input is on the blackboard. So it can definitely start from here, and then it produces a discovery intent, out of which the recommendation from collection intent is an implementation of that one. And that's really how Embabel decides how I'm going to chain these things together. Yep. So that's how this agent worked. Inside it is whatever business logic you need. So let me open. So this suggest collection essentially has a prompt. You can put whatever you like in it, and then you specify if you wish to change the model, which one you want to use. And then the result of that will be a strongly typed domain object, right? So it's easy to test, it's easy to predict because everything works through your domain objects and not through strings, which is quite important. Okay, let's head back here and let's get to the next one, which is suggesting a collection expansion. Now, because I'm using this chat mode in the shell, it uses a utility AI, I think, behind the scenes. So it's actually maintaining our conversation history. Okay, that was pretty fast. Okay, so it's gone and evaluated that. I'm going to show you because it's easier to read on the screen than in the logs. Here's what it did. By now, you can start to recognize this pattern. It chose the music discovery agent. It interpreted my question, and it decided that it needs to get to the suggest expansion goal. It has the suggest collection expansion object, which it derived from my prompt. And then it used a couple of tools. So the tools I have is fetching artists or fetching related artists. These are just Cypher queries under the hood, right? I use Neo4j OGM for this. So basically makes a query out to Neo4j and comes back with whatever data. And then because it also has the shape of the graph, it does a bit of reasoning to say, okay, is this in line with any of the clusters I actually have? And it does find that, it is in line with clusters 3 and 4. And then it goes ahead and says, okay, here are 3 potential artists that you can add to the graph. Right, so now I'm actually going to take that first artist and add it. Oops, there should be here. Yep. Right, so let's see what this one is doing. So very similar pattern into how it figures out which goal, which path it wants to evaluate. But what it does in this case, and what you're not seeing here, is it invokes a standard service, which is JDBC over a Postgres. It goes and it fetches the artist and the album that I've asked it to fetch from Music Brains. Then it comes back. It makes the LLM calls to get the summary. And then we have some business logic in there, which is, again, triggering various Cypher statements to update the similarity edges, rerun the projections. And this helps because we need to make sure that when we next want a recommendation, that the new artist and the new album is very much part of the graph, and it's possibly as well maybe shifted slightly the shape of your graph. Okay, did this work? Yeah, add it to your collection. Okay, let's go to the next one. So this was a really, really simple one, but it shows you how Embabel actually plans. Now we're going to get to the more complex agent. Now for this one, we are still going to use the GOAT method of planning, but we are going to use states. So states are really useful when you want to do branching and looping and so on. So before I get into the code, I want to show you what we are going to do in this. So there are a couple of stages in here. The first stage is to extract entities, right? and create paths, right? So what is the user asking for? Where are we going from this artist to this artist to this genre to this genre? And the goal of stage zero is to create paths. Now this is done through GDS, Jens, K shortest paths. The next two stages are actually closely coupled because they can call each other and keep looping. So the first one is evaluating the paths. So now we give these paths to an LLM and say, what's the best path, right? Not only what's the best path, but is the path acceptable? And by acceptable, it will actually look at the transition of artists and then say, okay, good, or no, this pair is pretty weak, not so good. If it was good, we skip over the expanding collection stage, go straight into, picking up that path, pulling out the albums for each artist, and then, returning, building a bit of summary and returning to the user. But if it wasn't acceptable, then the LLM is going to basically say, okay, here's my weak pair. Let me go and find an artist that I think would stylistically bridge these two, maintaining some form of continuity. Go to Music Brains, fetch the artist, add it to the graph, update all the similarities, reevaluate the parts, right? So when you have these stages, which I think is pretty neat, the end of this stage is to return an object of type evaluating path stage, clear the blackboard. And remember, this is kind of like the memory that the framework is operating on, because you're really starting from scratch, right? We don't want any of the old stuff. We wanted to freshly evaluate new parts and repeat. Now, this can and does go on endlessly, depending on how helpful the LLM wants to be, how stubborn it wants to be. So we have a cutoff here. We wanted to try only for 2 attempts and then stop. I think this is really important because when you're building things like this, you also have to think about what makes sense. Does it make sense for it to loop endlessly, keep adding artists to your graph? For this particular use case, the answer is no, because what it would do is it would dramatically change the shape of my collection and possibly even no longer align with my tastes, right? So if my collection is sparse, so be it. We can't build a path. I need to get out there, buy some more albums, improve my listening taste, and come back. Yeah. So these sorts of guardrails are really important, but they need to be thought of deliberately and how you want to influence the end result. Yeah. Okay. So what are we going to do? I am going to let this run. Now, this one is a very challenging path, and I will tell you why the moment I set this off. Okay, so I'm going to get out of chat mode a bit and just go into standard execution mode. I'm going to capture the prompts and the results in case we need to come back. So this one is a challenging path because we're really asking the agent to find us a collection of albums that goes from this arena rock, guitar heavy, Bon Jovi, all the way to a very emotionally intense vocal led Portuguese traditional fado performance, right? They are literally a night and day, right? So it's not going to be an easy path to find. But I think this also exhibits how the agent loops and where it should give up. So this is while that's going on, this is really the path that it actually took, and I'm going to show you a better view of this here. So what this agent did is, or what it's actually doing is, it extracted the parts. Okay, this is all cool. And then these are the 5 parts that were created out of Neo4j GDS Jens algorithm, right? Sure. And you see that it has found these 5 parts. So it did find a path. But when it went through the evaluation phase, it rightly rejected this pair. Every path actually contains this pair of Linda Ronstadt to Gordy de Trajano. And what it has in this is it basically gives you a reason as well to say, like, look, this is a really big listening gap. And any fan will know that it's a very jarring kind of transition. So now we start to enter our loops. We get into the first expansion loop where the LLM looks at this pair and says, okay, I think the best artist to bridge these two is Joan Baez, and that one, she brings in this rock folky style with some traditional world music, fair bridge, right? So the artist is fetched, put into the graph, parts are recalculated, retransition, and now we are back to the evaluation phase. So now we're in evaluation phase 2. You can see that she has made it to path 5, right? Sometimes it doesn't, depending on how the similarity gets calculated. But here she did make it. However, the LLM is going to reject it once again because now, while it probably likes the path, it really doesn't like Sting to Triana, and that is a bit of a weird shift. So it's going to go back and try to now bridge the gap between Sting and Triana. Here is where, I mean, it couldn't have planned this. Here is where it hallucinated, and it actually picked an artist, Triana, which was already in our graph. You saw me add it, during this demo. It was there when I recorded this path. And that's important because we have guardrails in there to say, let's check if the artist already exists. If not, we're going to reject, and we're going to add it to a block list. So when we reject it and we evaluate again, we are going to instruct the LLM to not consider it. I cannot tell you how many times it ignored the block list. So these kinds of guardrails are really important. So we say, okay, go back and expand. But at this point, right, we've exhausted our budget, right? We have no more budget. We're going to exit out of here. We are going to select the best path, which is this one, build a playlist. So we're going to select albums. Then we're going to give it back to the LLM to say, hey, can you check these albums? It's going to say, okay, I don't really like the 1987 album because the transition isn't very strong. It's going to look into my own graph, swap the album for a better Whitesnake album, and then build your playlist with an explanation that I will not read. It's still a bit of stretch, but not a bad attempt. And this time it honestly gave up, right? So I don't want to go through all the code here because it is quite large, but the main things I want to point out, and I'm conscious of time, is states, right? Conditions that you can use for branching logic. And then the rest is pretty much the same. So the only thing you're doing is you're taking your actions and you are wrapping them into various stages. So this was stage 1. Then you have stage 2. And what Embabel enables you to do is really navigate between stages by simply deciding to return an object that moves you from stage 1 to stage 2, right? Okay, so things that really matter is, first of all, you should always consider whether you need an agent. Sometimes you just have a very normal, boring, old style non-LLM flow, right? Service methods. Do you really need an agent? Do you really need the do you really need to build so many guardrails when it could have been straightforward code? Deterministic flows are still really important. They're useful for testability. Everything doesn't have to be non-deterministic. And real systems have gaps and limits, and these should be respected. So where you put in your cutoffs, where you put in your budget expiration, and so on, where you decide to retry, where you decide to fail. And with that, I think I'm almost at time. Thank you very much for attending, and I hope you enjoyed the session.